Good evening, students. I am Asop sir. Today I am taking a class on the last topic of SFBM, that is overhanging beam. So before starting the topic, I want to mention one point which was omitted in previous class due to technical reason. So let us see the point. In the problem, there was m moment of point m equal to 3.75 into 3 plus 0.75 into minus 5 into 0.75 to y, because moment of the point m will be the moment of the all the unbalanced vertical forces. Therefore, at first the effect of reaction A will be on M, and also the effect of UDL also present on M. So at first the moment of RA will be equal to 3.75 into 3 plus 0.75, as this A to C is 3 and C to M is 0.75. Therefore total distance is 3 plus 0.75. So the shear force of RA is 3.75 into 3 plus 0.75, and the moment of UDL will be, as the value of UDL per unit length is m. So the here UDL is present up from counting, which will be count is the C to M. So C to M, distance of C to M is 0.75, and for UDL the distance will be actually taken as the midpoint of the length. So 0.75 2. So this is the force and this is the distance. So this is the moment of UDL, and this is the moment of reaction RA. So the summation of these two will be the moment on point M. As reaction force is upward, so it is present, it is positive, and the UDL is acting downward, so it will be negative. So the summation will be 12.66 kilonewton meter. And now putting this value on this point on this line, taking some value which will represent at 12.66, and now this is the value 11.25, and now this addition of this 2 point will represent a parabolic curve due to UDL by the law. So this will be parabolic curve, and this is 0, and adding this 2 point, this will be also a parabolic curve. So this is the point. Okay, now I am going to the next problem, next topic, overhanging beam. So overhanging beam actually will be which will extend which extends or overhang some part after the support. That is, we can say that simply support, if some part of a beam which is extended after simply support in one side or both side, then this type of beam will be or will called a overhanging beam. So for overhanging beam, so for calculating the SF and BM, calculating SFBM, we can treat overhanging beam as a combination of simply supported beam and a cantilever beam. So for calculating SFBM, we just calculate the as the cantilever as the SF and BM of simply supported beam as and cantilever beam together, and this will be this will give the result. And here one extra point should be mentioned, that the point is point of contraflexure. So the point of contraflexure, what point is this is the point where the bending moment will change sign from negative to positive. As we know that for simple supported beam, the BM diagram will be positive, and cantilever beam, the BM diagram will be negative. So this is overhanging beam is a combination of these two. So obviously there will be one point where the BM diagram will change from positive to negative or negative to positive. So this where in that point the bending moment diagram changes its sign, it will be called a point of contraflexure. Now go to one example or one problem of simply supported beam. Let's see the problem. An overhanging beam ABC is loaded as shown figure. Okay, this is the figure. one overhanging beam, ABC ABC beam. This is loaded this type UDL, total length according to total length, and this length is 3 meter, this will 1 liter. Now we have to calculate the SFBM diagram and also SFBM calculation, SFBM diagram result and diagram. So at first we have to find out the reaction at the point A and the point B. So taking moment about point A, RA into 0 plus RB into 3, as the distance from A to A is 0, therefore distance is 0, and for B the RB, this is the point B, so A to B distance is 3 meter. So this equal to this is the total reaction, and the total force will be equal to these reactions. So total force will be as 4.5 is the UDL value of UDL. It is up to distance 4 meter, 3 plus 1 meter, 4 meter, and as according to rule for UDL we have to take just a midpoint of the UDL. So the midpoint of the of length 4 meter will be as 2, so into 2. So this is the value of UDL and this is the distance. So this will be equal to this. So from this we can get RB equal to 12 kN and RA equal to 4.5 into 4, as this is total load, minus 12, therefore RO will be equal to 6 kN. Now for SF, for the calculation of SF, at first FA will be equal to plus RA, similar as previous problem. RA equal to FA will be equal to R reaction of A equal to plus 6 kN, as we get. FB will be equal to FB will, as the on point B point, on point B the reaction of RA is present, and also the effect of UDL is present. So here plus 6 minus, as RA is positive, therefore UDL is negative. RA is upward and UDL is toward downward. Plus 6 minus 4.5 into 3, as up to this the length is 3 and this is positive, and also plus 12, as the here the 12 as we get that RB equal to F, so 12 kN is also present on point B. So we see as RA is positive, so RB is also positive, so getting the result as 4.5 kN. And now FC will be as we can get FC as the point C, the effect of this force, that is effect of FB is present, and also the effect of this remaining UDL is present. So FC equal to plus 4.5 due to this, and minus 4.5 into 1, as UDL is negative downward, and the length of UDL, this portion is 1, so UDL value unit length into length, value per unit length 4.5 and into length, this is the value, total value of UDL. So this is equal to 0, so FC equal to 0. Now for moment, as MA equal to 0 due to law or previous problem, same type of previous problem, MA equal to 0. Now MB equal to, we can get MB by any one side, as from right hand side or from left hand side, any one side the result will be same. So we can get is by from right hand side, it will be easily, as MB will be equal to minus 4.5 into 1 into half, because if we get from right hand side, then this is the point B, and we are going from C to B, the distance is 1 and value of UDL is 4.5 kN per meter, so total value is 4.5 into 1, and due to the rule we can take the distance as the midpoint. So the midpoint of 1 meter is 0.5, that is 1 by 2 equal to half. So this is the distance, this is usual value of UDL. So this is the moment as minus 2.25 kN meter. And according to rule or same as the previous article, the previous problems, that MC equal to 0 at the end point. You see the moment is 0, so MC equal to 0. Now so we can draw the SF diagram at first. So take some point as FA or RA equal to 6. So take some point which will represent RA, that is take some value which will represent 6. So this is 6, this is 6. Now we can start from this as the FC is 0. So this is starting from just this point, and at point B FC equal to positive 4.5. so take some value which will represent 4.5. so due to UDL the rule, due to the rule, adding these 2 points, this 2 point will represent a inclined straight line. Now as there is reaction if RB is also present as 12, as we can get 12. So if this 4.5 is positive, therefore we can is also 12 kN force is also present. Therefore starting from this we should go downward up to 12. So from this take 12, that is this part is 4.5, so take this part as 7.5, that is total length will be 12. This is 7.5. so from this to this is 12, as there is also 12 kN force is present. So from this to this is 12, which will represent 12. Now this is 6, and this is from 0 line, this is 7.5, and adding these two lines, this will represent the SF diagram. This will be also inclined straight line because it is UDL due to rule, but here the SF diagram is changes from positive to negative at this point. Let the point is M, and distance from A to M is X. So similar type, take one baseline for SF diagram and one baseline for BM diagram, and add this point. So this is the SF diagram, and this part is also positive. Now what is the value of AM, that is what is the value of X. For determining X, we can get as previous problem, that from these two triangle, this triangle and this triangle, this triangle and this triangle, these two triangle as isosceles triangle, that is the equal, that is the same type of angles are equal. Therefore we can get from these two triangles as x by 6 equal to 3 minus x by 7.5, as this is x, this is 6. So similar side is, this part is total is 3, therefore this part is 3 minus x, and this part is 7.5. so ratio this by this equal to this by this. From this we can get, implies that x equal to 1.33 m. So the value of x equal to 1.3. So moment at point M will be as 6 into 1.33 minus 4.5 into 1.33 into 1.33 by 2 equal to 4 kN meter. Why this? Because moment at point M will be as the moment of reactions x6 into distance x, that is 6 into 1/33. This was upward, and at this point the reaction of this UDL is also present. So for reaction for the effect of UDL, value of UDL is 4.5, and after this length is 1.33, and for UDL we should take the midpoint of UDL as distance. So this is the force, this is 1.33 by 2 is distance. So this is one moment, and this is one moment, and this is positive, so UDL is toward downward, so this is negative. So this is the summation of these forces. So these moments will be the moment at m, that is mm. So mm will be equal to 4 kN meter. Now for drawing BM diagram, starting from A, starting from this point, it will be better. So starting from this, and as we get to, as MB is 2.25, so, negative, so it should be downward. So take the at this point, as this is UDL, so the bending moment diagram will be a parabolic curve. So at this, like this will be negative, this will be negative. Now here a point of contraflexure will present. So, for find out the point of contraflexure, let the distance from A to the point of contraflexure is y. It is any arbitrary point y. Okay, y. So y. So taking moments about moment on P,